be the final video in this set on Common Core geometry, examples, and different cases. The last case, the rule you need to know for Common Core geometry is how to find the length when you have a tangent and a secant. Let's begin. So how to find the length of a basic secant segment when it intersects to form an angle. In this case, that secant segment involves a tangent. So in this case, we have PB as our tangent and PAC as our secant. So this is our tangent and this is our secant. The secant and tangent are drawn from a common exterior point, in this case P, and the product length of the secant and its length of its external secant is equal to the square of the length of its tangent. So let's annotate that and see. So this PB is our tangent, this PA is our external piece, and this PC is our secant S. So if we take the tangent squared multiplied by the external, tangent squared equals the external times the secant. In this case, that's PB squared equals PA times PC. Other people like to use it as proportion. That's PA over PB, the external over the tangent, equals PB over PC, the tangent over the secant. So if you want to write it like that, it's external over tangent equals tangent over secant. The reason why this form is different than the last one, same as that idea. These two similar triangles, AB and BC, but both triangles share PB. So it's a problem of a geometric mean in similar triangles. Let's begin and continue. Solving for a tangent. They ask you to solve for the length of PB. In this given example, we have PA equal 4, AC equal to 8. Together, the whole secant is 12. We want to find PB, so we'll call X. So PB squared equals PA times PC. PT equals 4 plus 8, which equals 12. Means X squared equals 4 times 12. X squared equals 48. Take the square root of both sides, get X equals the square root of 48. Break down that square root by finding two numbers and multiply it. One which is a perfect square root of 16, one which is a composite number or prime number, which is 3, and square root of 16 is 4 root 3. We ignore the negative answer because we ignore it because we can't have a negative length. Let's do another example. Solving for the internal secant. It's a bit more algebra heavy. So PB, our tangent, is 12. PA is 4. We want to find the length of AC. So PB squared equals PA times BC. And we have 12 squared equals 4 times X. Now this is why. We make X the whole length, or you're going to make this a very ugly algebra problem. So we have 4X equals 12 squared, which is 144. Divide by 4. You get X equal to 36. And then to get AC, you do 36 minus 4, and you get your answer of 32. The other way to do it would be to do 4 plus X, which is much more algebra heavy, and I won't recommend it. This is an easier way. I hope this video can help this whole unit. I hope you please watch the 19 videos in order. That's the intention. There may be more videos added on to the set, going through the proofs of a lot of these videos in the past 19. Also, other problems that you may think you may have that I did not cover different types. I try to cover one of every single different type of algebra problem that is site. I did not cover any that involved the quadratic equation. Very heavy algebra because they're not usually covered in Common Core geometry on circles. We try to keep them to the ones I've done. There may be some more with radicals, some not more with radicals, some more with quadratics, some more with not quadratics. I hope to reach more. If you see one that you would like me to see, you post one in the comment and take a picture of it, and I'll go over it for you. The next unit covers the equation of a circle, which is the beginning of an idea of conic sections, which I may do a full set of videos on after this unit. The next unit will have 7 videos as planned. First video, which is the next one coming up, will cover the equation of a circle. Then the next video will cover graphings and extensions of the equation of a circle. Third video, we covered the equation of circle in standard form and the link to completing the square with maybe a video on completing the square. And fourth and fifth videos are completely enrichment topics, where I may do video 6 first, which is the equation of a tangent line to the circle, but question videos 4 and 5, equation of a circle given 3 points graphically, algebraically, are topics that link to Algebra 2 and are not really in any curriculum, but are interesting extensions. And then 7, one more video plus an extension to the conic sections. That may be one more video, but the conic sections are circle, parabola, ellipse, and hyperbola, and they're concepts that are sometimes covered in pre-calculus courses, one time covered in Algebra 2, and they're a very nice extension to round up the circular, elliptical unit ideas. There also may be one more video on the construction of a tangent line to the circle, which doesn't fit in anywhere. That's a construction concept, not a geometry of a circle concept or a circle algebraic concept. So this is the end of the unit on the geometry of a circle. The next is the algebra of a circle, as it's called. This is Mr. Spy, signing off.